I'm going to give you like some high-level overviews of main high-level feature capabilities we've added in. And this will be kind of like marketing-esque type slides. So once we get done with that, I'm going to give you guys a bit more of a technical deep dive into something named Project Enzo. Quick show of hands, how many people know what Project Enzo is, or have you at least heard the term? Very few of you. Okay, awesome. So let's start with the agenda. In case you missed it, I'm going to cover the recent updates in Horizon View, and I'm only going to cover the stuff that we've done since February of this year. So I'm not going to talk about what we did in 2014 and all that kind of crap. I want to talk about what Project Enzo is and what problems it's out to solve. We'll talk about what the key technical components are of Project Enzo and how Enzo is different from our competitors. Now, I'm not going to go out and slam our competitors and say, oh, they suck, this and that, whatever. I'm just going to talk about what we do that we think is interesting and different versus what competitors are doing. So, I said I was going to talk about 2014, so I'm not going to talk about that. But we added some features that were missing from our initial RDSH capability. So that was in 2014. In the first quarter of this year, we added smart card support for RDSH, USB mass storage devices for thumb drives for RDSH, HTML access for RDSH, and client drive access. Now this one's particularly painful because it's been missing from Horizon View forever, and it's a feature that Microsoft and Citrix have both had in their platform for a long time. So that came in the March 12th release of Horizon View 6.1. So I'm not going to read all these things through. I can send you guys a deck. You can read about it later. But effectively, we added smart card authentication so that you can pass a smart card through into an RDSH session or a VDI desktop and authenticate the user with the physical smart card. So that's good stuff. We had a USB device, a storage device redirection, so that this is, by the way, this is port level redirection. This is not generic USB redirection. That's a completely separate topic. But the port level redirection allows you to get access to the USB file system contents when you connect to a terminal services session without going through a very chatty USB protocol for accessing your files on your Windows Server session. By the way, this capability was always in the VDI, Horizon View VDI. It's just we didn't have it on terminal servers, so we added that in 6.1. HTML access to Horizon View desktops. So if you tested out the HTML access component from Horizon View, you can use a browser-based, no client, clientless solution and connect to a VDI desktop. We added support for the RDSH desktops because originally when we added RDSH support, we didn't have the ability to connect to an RDSH desktop, only to VDI desktops. So we added that. We've also added access to Grid vGPU and VDGA pass-through 3D desktops that was lacking from the HTML5 support in the past. We've added support for 2012 R2 desktops, as Benny and Sanisha talked about earlier. There's some use cases, particularly for service providers, where you want to host a 2012 R2 desktop as a virtual desktop use case, because you can take advantage of the SAL and SPLA licensing models from Microsoft, so you don't have to buy virtual desktop access licenses to run VDI. This is really big in the service provider market, not as big in traditional enterprise companies. We had a bunch of stuff that was required for federal customers, such as CAT card support, which is a form of a smart card. So we added that capability. We have end-to-end IPv6, which most customers don't really care about IPv6, but some federal customers have a mandate that they have to support IPv6, at least in the US federal government. We applied for common criteria. We are not yet, we don't have common criteria certification, but we've applied for common criteria certification, which is the first step. And then this, which people in Europe don't care about, but there's a federal standard named FIPS in the US government that you won't get in any federal customers without FIPS compliance. So we've applied for FIPS compliance as well. So virtual desktops with 3D graphics. So in vSphere 6, which was the release of the hypervisor that came out in February, the capability to allow the hypervisor to pass through the NVIDIA Grid capabilities for virtual GPU was added in the hypervisor, but it was not exposed into Horizon View for VDI desktop access until the Horizon 6.1 release. So we added that capability in. And there's been plenty of sessions on NVIDIA Grid vGPU, so I'm not going to go into all the technical details, but I'm happy to chat after the session about how this all works and if you have any questions on it. Virtual SAN was a technology that came out a while back. What changed in the March release and then actually in the February hypervisor release is we basically doubled the scalability of vSAN. So if you're leveraging vSAN as a distributed data store for building terminal server or VDI desktops, we can now do 2x the amount of desktops, 2x the amount of desktops per cluster, and more hosts per vSAN cluster, so there's more scalability. Virtual volumes is a storage quality of service capability built into the hypervisor that allows multiple different third-party storage area network providers to leverage this storage policy control in the hypervisor so that you can perform per VM level storage quality of service enforcement. So previously, there wasn't really a way to do it at a per VM level. You could do it at a data store level, or you could do some very limited I/O control capabilities on the hypervisor. But this is a way to do a storage agnostic approach to do storage quality of service. So EMC, NetApp, whomever can all take advantage of virtual volume support for enforcing quality of service at a per VM level for storage. This is very, very exciting stuff. A lot of storage area network providers have adopted virtual volumes as well as some software-only solutions. So a very exciting capability. This was in vSphere 6. Client drive redirection, a feature that probably should have been there 6 years ago, but somehow managed to not make it into the product, is finally in Horizon 6.1.1. Horizon 6.1.1 we just launched general availability of last Thursday. So you can now do client drive access to access your C drive, your network drives, your locally plugged in USB storage devices, and get access to those in a VDI desktop or a terminal server desktop. As I said, this is something Microsoft and Citrix had for many, many years. So, hey, better late than never. Anyway, it's supported today on Windows endpoints, and there's a tech preview of Mac. We'll be bringing support to other OSs as time goes on. HTML access for RDSH apps. As I mentioned, when our HTML5 support first came out, it only supported VDI desktops. Then it later supported RDSH published desktops. It didn't support RDSH published apps. So the 6.1.1 release with our HTML5 support now supports RDSH published apps. I have some screenshots that I took out of this deck to kind of show you how it works, but I'm happy to share this with you guys after the fact, or just download a trial and check it out. Serial port redirection. Now this is a feature that people are like, why did you put this in here now? Like, nobody cares about this anymore. The reality is there are some customers that have equipment, particularly in medical organizations and stuff like that, where they use a COM port to connect to a terminal server or virtual desktop. And what people were needing to do is use COM port to USB adapters and then pass USB redirection to the virtual desktop. So we've actually added serial port redirection, so now you can pass your COM port directly into your desktop solution. So that's been added. We also added Windows Multimedia Redirection for RDSH. We had it for VDI for some years now, but we enhanced it to support for RDSH use cases. This is Windows Media Redirection only. This is not Flash. This is not other alternative media formats. So there is a dependency on Windows Media Player or the embedded media player inside Internet Explorer. We added Smart Card for RDSH hosted desktops and applications. The change, because I mentioned we did that in the 6.1 release back in March, so what's different between March and now? Between March and now, we added extended support of Smart Card redirection to iOS, Android, Mac, and Linux clients. So we're now supporting a diverse set of endpoints and allowing Smart Card to pass through. Now, of course, you have to have a Smart Card reader that works on an iOS device or Android device, but there are readers that interface with the ports on a mobile device to pass the smart card through to the virtual desktop. Google Chromebook, we have support right now with HTML5, which you can access from a Chromebook, but the challenge is that inside the browser there are security restrictions that prevent you from accessing things like the clipboard of the local operating system, or access things like webcams and client-side microphones and all these types of things. So what VMware has decided to do with our Chrome support is, about a year ago, Google decided to allow Android applications to run natively in a sort of a sandbox fashion on Chrome OS. So what we decided to do is to take our Android client support and port that in as our Chromebook native client. So now we can take advantage of things like copy and paste as a keyboard shortcut without having to click on the screen to get access to the clipboard. Now you can just do Command-C, Command-V, or Control-C, Control-V, and that gets pasted into the Chromebook automatically without having to do a lot of other messy things. And as I mentioned, webcams, client-side microphones, all these things can be enhanced over time so that you don't have to use a non-Chromebook client to get those capabilities. You can support it on Chrome OS now. Linux desktops. Now, most of the people in this room, I suspect, are Windows people. So you're like, why does everybody care about Linux? Like, Citrix is doing Linux VDI, you're doing Linux VDI, like, who cares about Linux? First of all, take a trip to China sometime, and you'll find out exactly who cares about Linux. There is massive, massive opportunity in the neighborhood of literally millions of seats of Linux virtual desktops in the market. Well, that's to be determined, I suppose. But it's not. This is not only an Asian market scenario as well. I talked to a retail customer that had 3,000 Linux developers that were building their application platforms, and they were basically using a Windows desktop to get an SSH session into their Linux server to do their development. Now, we would all sit there and go, why would they do that versus do a VPN and SSH? Their security policies only allowed people to hit a desktop connection through the remote access solution, so they had to terminate on some kind of a desktop, which today it's a Windows desktop that they're just using to SSH to a Linux server. So this customer has an interest in displacing 3,000 seats of Windows VDI because all they need is Linux SSH connection. Why would they do a Windows VDI desktop and pay all the licensing? So there are use cases in customer environments today for thousands and thousands of seats of Linux, not to mention like educational institutions, universities. Linux is a big deal. Now, some people say, and I've heard this rumor, that oh, VMware just did this because Citrix announced it. This product has been in development for like 2 years. We didn't just turn around and say, oh, let's make Linux VDI. It's been happening for a long time. VMware just didn't go out and really make noise that we were building Linux VDI, but we did launch our tech preview after Citrix launched our tech preview. But the good news is we actually beat them to market on GA. So this got released on Thursday. It supports Ubuntu, RHEL, CentOS, and some goofy Chinese Linux that I've never really heard of before. And I want to actually show you guys a video, because one of the cool things that we did with our Linux solution is we're actually supporting our VBGA graphics capability for passing an NVIDIA Grid GPU into a Linux virtual desktop. And so you can do some pretty cool stuff. Now granted, this isn't a LAN-based scenario, so over WAN, latency, all this kind of stuff, your experience is not as smooth as this is, but here you've got UniEngine running a 3D demo on a Grid K2 GPU on a Linux desktop, accessed remotely, so that's pretty cool stuff. And you can run applications that are not, game engines. You can run things like Blender. And here we've got a Blender demo of this cool little gasoline thing, spraying fire all over the place. So, this is 3D graphics on Linux. So there's a market for oil and gas that uses tons of Linux-based applications. That's probably bad.
Really? See oil and gas in your picture. That's good.
Yeah, that was great timing. But yeah, so oil and gas industry has a huge amount of Linux use cases, and having VDI that can support 3D graphics is
There's a high demand for that. Absolutely.
So that's Linux desktops. Now, I want to spend the rest of the time talking about Project Enzo. So there were only a few hands that went up when I talked about who has heard of Project Enzo. So I'll give you guys the 20,000-foot view of what Project Enzo is all about. And by the way, everyone says, oh, Project Enzo is something that you just announced because Citrix announced Citrix Workspace Cloud. And that's absolutely not true. The underlying technology behind Project Enzo has been in development for about 18 months. There's something internally called Project Astro, which is a set of API extractions and single pane of glass web management for virtual desktop technology that we've been working on for a little over a year and a half. But from a timing perspective, we did, of course, announce this product right before Citrix Synergy, of course, to get PR and all that kind of stuff. So what Project Enzo actually is... What's that? Oh yeah, my good friend Gunnar like to take a little jab at me on Twitter, but whatever. So I will give you the gratuitous marketing slide that describes what VMware tells people Project Enzo is about, and we'll talk about what it's really about. So the major objectives of Project Enzo are simplified desktop setup. So your first virtual desktop should be up and running in under 60 minutes. That sounds pretty simple, makes a lot of sense. And we all know VDI architecture can be challenging to implement, so if you can make it 60 minutes or less, that seems like a good idea. Second thing is unbelievably fast scaling, 0 to 2,000 desktops in under 20 minutes. Now, since Sinisha and Benny brought this up, is who needs 2,000 desktops in under 20 minutes? I'll tell you the reason why. We have been in a position where myself, I've done tons of persistent VDI over the years, and I've convinced a lot of people that persistent VDI is the best way to go because it's simple to implement, there's no barriers to entry, and you can just deploy your desktops. Unfortunately, it still has all the same complexity of management and support and security challenges that normal physical desktops have. So, non-persistent is a better solution. It's just hard to get from persistent to non-persistent. It takes a lot of work. So, VMware's point of view on this is last year we announced something called Project Meteor at VMworld. And Project Meteor was a combination of two technologies, something called Project Fargo, which we used to call VM Fork, it's now called Instant Clone, and our App Volumes technology, which is our layering software for delivering just-in-time applications to virtual desktops. So to go back to the question of why do you need 2,000 desktops in 20 minutes, the answer is simple. If I'm going to move from persistent to non-persistent, and I have to recompose or refresh my virtual desktops nightly or weekly or however frequently, if I've got 100,000 virtual desktops, it better not take me 6 weeks to roll them over. I better be able to do it over a weekend. So that's why we need 2,000 desktops built in under 20 minutes, because we will be rebuilding our base image effectively every weekend or every month for every single Patch Tuesday event, because you got to refresh all your base images for all your patches. You could argue like, well, you could just patch the machines while they're running, but you have to reboot for the patches to apply, so you've got to reboot the machines, and on non-persistent, once you do that, boom, all your changes are gone. So you have to have a way to scale it out very rapidly. The other thing we're focused on is zero downtime upgrades, and this is zero downtime upgrades end-to-end. What I mean by that is you should have a zero-touch way of rolling out hypervisor upgrades, vCenter upgrades, broker infrastructure upgrades, and Windows Lifecycle Management for imaging apps and the whole bit, without having to actually take the entire environment down. So you should be able to actually roll over image updates, roll over hypervisor upgrades, roll over broker upgrades without users noticing that the desktops are unavailable. We'll talk about how that can be done in just a bit. And then one of the things that we're focused on is what we call hybrid cloud flexibility. So today, VMware View for most customers runs as an on-premises offering. As you guys know, we made an acquisition of Deskstone, which is a desktop as a service offering back in 2013. And Deskstone runs in the cloud, in the public cloud. So there are some customers that say, I want some cloud desktops for certain use cases, and then I still want some on-premise for some other use cases, but I want to have one way of managing desktops in the cloud and another way of managing desktops on-prem. That seems silly. It's like literally different UI, different steps to manage it, and all these kind of things. So we thought a lot about that and said, if there are use cases to drive DAS and use cases to drive local, why don't we give people a consistent way to manage it wherever those desktops live? And that's what Project Enzo is aiming to do. So the Horizon View technology is being replaced long-term with this next-generation desktop as a service architecture, which is Project Enzo. It doesn't mean that Horizon View is going away tomorrow. It'll probably take somewhere between 1 to 3 years to kind of start rolling customers over to the new architecture. But the intention is that eventually the same architecture will sit in the public cloud as in the private cloud, and we'll have one way of managing with a single pane of glass, regardless of where the workload actually lives. So that's the intention. Also, desktops that cost less. Now, I don't know about this whole cost of a cup of coffee. I think that's a nice marketing term. But effectively, what we're driving towards is you need to make a cost-neutral decision for virtual desktops to be successful. I can't have a VDI desktop cost $600 and a PC cost $300 because no one's going to buy it if it's 2x. Well, limited people will buy it for the agility benefits, but you want to make it to where it's cost-neutral, and then it becomes, there's no barrier. It's like, well, why wouldn't I buy a virtual desktop if it's the same price? And I get more business agility benefits. So we have a tech preview of this launching. There's a tech preview website. You can go vmware.com/go/Project Enzo. And on that website, you'll find all sorts of great fluffy marketing things that describes how it works and printing animations and demos and pictures and all this kind of stuff, which I'm not going to show you. General availability is planned for second half 2015. So, tech preview we're targeting in second half 2015 and GA in 2015. So that pretty much means these things are happening, pretty quickly after each other. So that's what you can expect there. So what problems will Project Enzo actually address? First of all, we are building Project Enzo on top of our Evo Rail offering from VMware, which is our hyper-converged appliance offering. Now, there are many different providers out there that are doing hyper-converged appliances. What sets the Evo Rail offering apart from some of the other vendors is we're not locking you into any particular hardware vendor of choice. If you want to buy servers from EMC or Dell or Lenovo or Fujitsu or whomever you want to buy from, the way that Evo Rail works is VMware creates a reference hardware spec and tells the vendors to build the hardware however they want, as long as it has this amount of CPU, this amount of RAM, this amount of disk, SSD, and spinning disk. And then any vendor can turn up their hardware part number and offer it to their customers as an Evo Rail certified piece of hardware. Then our Enzo technology will sit on top of Evo Rail that will ship from the factory with Enzo pre-configured. And I'll talk through the architecture of how it actually gets rolled out. Today, you can order Evo Rail equipment that you can basically self-install your own VDI stack on top of it, whether that's Zen Desktop or RDVH or Horizon View. You can basically just build it like any other virtual server infrastructure in your data center. The difference is we're trying to automate a lot of the complexity of what goes into building out a VDI architecture. We're trying to address the CapEx of building scalable virtual desktop infrastructure. I'm saying virtual desktop. I don't discern between VDI and RDSH. They're both virtual desktops. So it doesn't matter whether it's VDI or RDSH, we're going to give you the same tools to build out that architecture. We want to be at or below the cost of a PC. So basically targeting somewhere in the neighborhood of $250, $350 from a capital expenditure perspective. That makes it cost neutral and the decision becomes very easy. We also want to address the OpEx costs of managing virtual desktops. There's a general rule of thumb that says your OpEx in a well-managed environment will be between 2 to 4x that of your CapEx costs. So if you pay $300 for a or $300 for a physical desktop, you're going to be paying anywhere from $600 to $1,200 to support that machine, which is building a base image, packaging software, pushing software, inventorying software, maintaining software, retiring software, help desk, ticketing, support, all that kind of stuff. And our belief is with our technologies like app volumes and this instant clone VM fork technology, we can drive down the cost of managing the virtual desktop to get it to be not neutral with CapEx, but closer to a 2x or 3x factor rather than 2x to 4x or maybe as high as 10x for a poorly managed environment. So I already talked about that. So I talked about where all the OpEx costs come from and what we're hoping to cut out through our management. And when these OpEx costs get reduced, we can now redeploy resources inside the organization. Because the challenge that you have with OpEx is the only way people have to calculate OpEx is they take headcount and average salary and multiply it and say our OpEx for our desktop infrastructure is this amount of millions of dollars. So on a per desktop basis, it's $800 or $1,000. Now, if you go to a customer and say, we can cut your OpEx in half with this tool set, therefore you can fire half of your employees, that's not going to go over well. I don't know how it is in Europe, but in the US, certain managers have a manager role because they have 15 people working for them. And if you tell them they can fire 7 of them, you're no longer a manager. So most managers are not interested in you cutting half their headcount. What you can tell them is say, look, if we were able to cut half the number of hours it takes to manage your desktop infrastructure, think about all the other projects you could reassign people to accomplish rather than being swamped in PC lifecycle management. So that's kind of the sales motion to get customers interested in the idea of an OpEx reduction. So, what does Enzo architecture actually look like? There's only kind of 3 main things. Workspace portal is irrelevant. In this case, it's just where people go to get to their desktops and apps. The 3 main pieces of the infrastructure are Enzo-ready infrastructure. And this is, as I mentioned before, the first go-to-market motion is to put it on top of EvoRail because it's hardware that we own and control the build configuration for. So it's easy for us to be able to do the integration to make it work great out of the box. However,
a question, which
yes.
version of EvoRail? Because there will be a new version also. It's on EvoRail as we know it today.
It's the same effective SKU, but at some point in time in the future when Enzo is ready, the EvoRails that are being shipped will come with a new software stack. So it's the same hardware, it'll just be a different software build. For people that buy EvoRail now, there will be a way to take Enzo and deploy it on top of that rail. It just won't come factory shipped with Enzo pre-built, but it's the same hardware. So that's the way that we're going to market originally with EvoRail. However, we're having conversations with a number of different hyperconverged appliance vendors. I presume you could name who the top 3 or 4 are. And we're trying to do integrations with them as well, so that if you are a customer of Nutanix, SimpliVity, Pivot3, Atlantis USX, whomever, you can still take your hardware investment and leverage our Enzo technology on top of it and not have to replace all your hardware to get the advantage of this technology. And then we're also looking at doing a Horizon 6 adapter where we'll take existing on-premises legacy Horizon View, version 6, obviously, not even before 6, and we'll be able to connect it into the Enzo cloud control plane. There's a software component of Enzo that gets pre-delivered as a virtual appliance on every hardware appliance. And this smart node component is what's responsible for discovery of other smart nodes and the orchestration and automation of the workloads that run on that hyperconverged appliance. So these smart nodes can live on premises on your hyperconverged appliances, and they will live in the desktop as a service offering from VMware and from our vCloud Air network partners. So anyone that runs our infrastructure stack can run a smart node and host a smart node enabled or Enzo enabled desktop infrastructure. Now, sitting at the top of the Enzo solution We have application management, we have user environment management, we have image management, as well as monitoring and analytics and infrastructure upgrades, as I talked about rolling infrastructure upgrades. So why did we bring these things together? What we're trying to do is build what most people in IT realize is a really good idea, which is a service catalog, or a set of service definitions that makes up an experience. So in a typical PC lifecycle management world, when you deliver something to an end user, you're typically giving them an image, you're giving them some apps, and you're giving them some policies that defines how their desktop looks and operates. We're taking those assets of Next Generation View Composer, which is the VM4 instant clone, that's the image management piece. We're taking app volumes, app stacks, and we're taking the UEM technology that controls user policies, and we're putting them into service catalog definitions. So when I want to build a VDI service for my customers, I say, take this image, take these app stacks, take these policies, go build me 100 of them, go automate it, go build it. And it will automatically scale out the environment based on what I've requested and build the environment out. So what is an Enzo Smart Node? It's a self-contained unit of software that is purpose-built for these orchestration of a desktop workload. So it's not a hardware device, it is a software virtual appliance that will sit on top of the hyperconverged appliance as well as up in the cloud. And it can operate as an on-prem appliance, as I mentioned for Eagle Rail, can operate in the DAS platform, and we'll be able to tie in Legacy View as well. But I do say there will be different capabilities depending on which platform you're on. So for instance, on our infrastructure, we will have a fully orchestrated rollout upgrade process. If you're tying in Legacy Horizon 6, we can't predictably ensure that we can upgrade and roll out the environment because we don't know what your backend infrastructure looks like. So we may have different capabilities depending on what the backend is. We will provide an on-ramp from existing platforms to Smart Mode, so we'll basically have a way to kind of import your legacy environment and Smart Mode enable it. The Enzo control plane, it's a next generation cloud management layer built on cloud native application stack. So it's basically AngularJS. All this is built as a cloud native platform, and it will be the same whether it's on-prem or up in the cloud. This is operated by VMware. It's hosted on vCloud Air today, but we are looking at packaging this for an on-premise deployment for those customers that are federal, healthcare, financial services who don't want to have a control plane in the cloud. That will be coming at a later date. It's not something we're focused on right now. So we're focusing on common management and orchestration across all smart nodes. So this is truly a hybrid delivery model, meaning desktops can be on-prem or in the cloud, and the orchestration technology will work the same regardless of where the workload is. Now there are some people that say this will enable us to do cloud bursting or moving workloads back and forth. I think cloud bursting is an idiotic idea, and I think very few people really care to do that. They more care to define what workload they want to run where, based upon where the data backend services are, and predefine where the workload is. There are some use cases where cloud bursting may make sense if you've already pre-configured the workload in the cloud and just want to burst capacity. But I don't see the idea of migrating workloads back and forth as being a good idea. Application metadata is stored in the cloud. All user data that goes into the virtual desktop will be stored on-prem or possibly in the smart node. We're still determining if we should actually bake file services into the smart node itself or have a separate file server set up. As I mentioned, we'll do private cloud deployments for financial services and federal use cases. Hardware appliance is hyperconverged hardware, will be the first generation smart node. Down the road, we'll be doing others, as I said. And we're doing a tight integration with infrastructure stacks. We can do rolling upgrades of vSphere, rolling upgrades of your virtual center appliance, rolling upgrades of the broker without you actually encountering any downtime. And by the way, this is designed to be a scale-out architecture. So if you install one hyperconverged appliance with one smart node, it will build out the HA components on the 4 nodes that are there. You get a secondary appliance that will basically build out redundant infrastructure across all the nodes in the cluster so that you don't have an outage of broker or vCenter components or anything like that. So differentiating features of individual hyperconverged platforms. So we will have different Evo partners who will have different Evo Rail capabilities above and beyond the base functionality, so we'll be able to take advantage of that in there as well. And automatic software updates for the entire stack, inclusive of vSphere, vCenter, and all the other SDDC technologies that are built into the software license environment. So technical components, what's in it? It's a 100% Linux stack. This is very different from existing legacy View, where View is based on a Windows server platform. So these virtual appliances are all Linux. So, and so is the next generation View Composer. So the future architecture for View will be all Linux-based for the infrastructure hosting components. The desktops, of course, will still be Windows if you want to host Windows desktops. So Horizon DAS, we're putting up into vCloud Air, so there'll be an appliance up there. We have a next generation remote access gateway named Access Point that is a hardened Linux appliance. Basically provides all the functionalities of the prior generation View Security Server on a Linux appliance that will replace the View Security Server component. And will support hierarchical deployment for DMZ placement. We have a point of presence component that actually sits on-prem that allows us to do things that are required for situations where you have to have global entitlements, where a desktop is here in one circumstance and a failover desktop in another location. We have this bootstrap appliance, so as soon as the smart node gets powered on and brought up, this smart node appliance automatically initializes and starts rolling out the infrastructure. When you basically sign on to the cloud connector, which you create your My VMware login, and you basically log in and say provision me a hybrid cloud management account. And when you do that, then it will talk to the smart nodes that are on-prem and smart nodes in the cloud, and it'll pre-configure the environment for you. And then as I mentioned, VM Fork, App Volumes Manager, and the UEM components are pre-built into the DAS platform, so you don't have to set those up separately as separate installations. It's all handled automatically. So the Bootstrap OVA appliance, as I mentioned, it connects to the control plane. It basically deploys the infrastructure after you've applied the vCenter address and credentials and your IP address, NTP info, DNS. Initial authentication is done by your My VMware login, and then there's a secure independent pairing set up between the local point of presence component and the cloud environment hosted on vCloud Air. And then all the smart node software and appliance templates are immediately downloaded and deployed for you automatically. So no more do you have to go in and install and configure View Composer and View Broker and all that kind of stuff. This does the deployment automatically based upon how many hyperconversion nodes you have running in your environment. So I know I'm almost completely out of time, so let me just say, how is it different? Initially, we're focused on greenfield deployments. We're not trying to focus on brownfield replacements because that's a very complex thing to get right. So we're focusing on greenfield. If a customer wants to roll to this architecture long term, they would basically just roll it over a third of their environment every year, and 3 years later, they're completely on this new architecture. But we realize people have to live side by side for a while, so that's why we're going to tie the Horizon 6 adapter to bring in your legacy environment. We're focused on the CapEx cost of a virtual desktop with the Evo Rail solution, but we're also focused on fixing the operational costs that you have today with traditional PC lifecycle management through App Volumes, UEM, and this instant clone technology. We're also engaged with a large number of hardware providers to give customers choice on who they buy servers from. If you're a Dell shop, buy Dell servers. If you buy EMC servers, buy EMC servers, Fujitsu, so on and so forth. So we're not locking you into a particular hardware vendor of choice. So I'm out of time. What question?
Yes, because it's based on Linux.
Yes.
And I've read that VMware will bring something to the community, the source code. Will the source code be released under the GPL?
That's a great question I don't know the answer to. I'll have to take that back and find out. Sure. So there's a website, vmware.com/go/project Enzo, or feel free to drop me an email or a Twitter DM or something like that, and I can answer any questions. So thanks for your time.